Let's now analyze some properties of an exponential. So of an exponential compared to a logarithmic function. Okay, the first of which, let's just look at the domain and range. So the domain of an exponential is all real numbers. And that makes sense because if you look at all the x values of your exponential, obviously it exists everywhere. Like this just keeps on going forever and ever and ever. It's all the x values. What's the range of an exponential function? Well, as you can see here, it's all the real positive numbers. And that's because you've got an asymptote here at y is equal to 0, and it's everything above that. So it's all the real positive numbers. Now, what do you know about the relationship between the domain and range of a function and its inverse? Well, hopefully you know that they switch. The domain becomes the range, and the range becomes the domain. So as you can see here, let's now look at the domain and range of a logarithm, which is the inverse of this. You can see my domain is now all real positive numbers. Let's look at our graph. As you can see, I've got an asymptote here, and all my real positive numbers are here, all real positive numbers. My range is now all real numbers, because as you can see, all my possible y values are just everything now. It exists all here, because this just keeps on going up and up and up forever. What else do we need to take notice of here? Well, for my exponential, my y-intercept is 0, 1. That's right there. And remember, if you do have some transformations, this could change. And over here, for my logarithm, my x-intercept is 1, 0. So 0, 1, 1, 0. It's just the inverse of each other. So we'll just switch them around. And also, the asymptote is the inverse of each other. This is y is equal to 0. This is x is equal to 0. So those are just some properties of the exponential compared to the logarithm.